Assalamu alaikum. This is an attempt to solve an exercise on structure query language which has been posted in week 4. So I would like to show you this exercise which I have put here on this link, week 4. This exercise is the text file which is on DDL and DML, that is data definition language and data manipulation language. And basically I will focus on the constraints. First, in order to execute these commands like create table, like alter table, insert into table, and then select from the table, and then also we can try other commands like update and delete later after we create the table and tables and populate them with some data. First, I ask you to download this application which is SQL Apex from this apps. So you have to go over these instructions on clicking here on Oracle Apex, extract this file, then follow this instruction to download and install the Oracle Database Express Edition, and then try some commands like you see here in this instructions. For those who would like to use XAMPP, XAMPP also is available here, and you can try to work with it if you want, but I would really recommend to use Oracle Apex because it's easy and straightforward. So after you install and create a password for the system user, and I explained that in the previous class where you need to create a user for yourself and then log in to that user using this URL, which is 127.0.0.1 :8080/apex, or instead of 127.0.0.1 you can just write localhost, one word, localhost :8080/apex. Then you would get this connection to the server 127.0.0.1 :8080/apex. Okay, here it is. Then you log in. You can log in as a system, or you can create a user for yourself and then give it a password. Then you log in as normal. When you log in, go to the SQL and then click in SQL commands. Here is where you can execute your commands, and then you can run them here using this icon, run. So let me first go over the create table command, which is, let me just copy this one and then explain it on this box, editor box of the SQL Apex. Create table student. I would like to create two tables. One of them is called student, the other one is called section, in which a student takes or registers in sections. For this example, I have this create statement, create table, and then the table name, which is student, and then these are the column names or the attribute names or the field names: student ID, first name, major, and reg date for registration date. This is the data type, varchar2. You can use char or varchar2 or number or date as the data type of these attributes. So the first one is student ID, because it's a combination of maybe characters, dashes, numbers. Then you can use varchar2, and then between parentheses here you specify the size of those characters, how many characters would be, like 10 or 15. Like if the name is they might be one of the student names are very long, then you can actually increase this one like this, for example. So here it is the maximum that you can actually specify for a specify character, how many characters for a specific field. Major, I put major 20 because some people, they can use major like ME for mechanical engineering, or they can spell it out mechanical engineering, which is very long, that you can actually have 20 characters. Here on this right hand side are the constraints. This is a primary key constraints, which means that this student ID is a primary key, which is a unique identifier for the rest of these attributes. And this is another constraint called not null constraint. Not null means when you insert data into the student table, you cannot leave first name uninserted. You have to insert the first name. So the system, the database management system, which is Oracle, will not allow you to skip the first name because you put not null. If you would like to have the choice of skipping it while entering the information, then you can just leave it without writing not null. And then of course you put a comma after the first attribute has been specified with attribute name, data type, data size, and a constraint. You go to the second one, first name, also the name of the attribute and the data type and the size, and then the constraint. If there is no constraint, just leave it without any constraint. Just put a comma to separate it from the previous one and the next one. The third one here is major or specialization. Major is a third attribute here for the student table, and its data type is var char2 with the data size 20, and then the constraint is unique. I should remind you that unique here means you cannot repeat the same value for the major. That means if you are entering values in the student table and you would like to enter, for example, students 1 in the student registered in mechanical engineering, you cannot repeat mechanical engineering. If you put CS for computer science, then you cannot use CS again, which is not convenient, of course, but I'm using it here only for example. Unless they want a student table to contain tables, one student from every major. So in this case, I would say this is convenient to create a table like that. But the reason of having it here is just for teaching purposes, is to show you that how you can create a field with a constraint called unique. A unique constraint is a constraint that doesn't repeat. So a unique constraint is not a primary key, although a primary key doesn't repeat as well, but we can say that every primary key is unique, but not every unique attribute is a primary key. Because you can have unique attributes like major, but it is not a primary key. And here there is another constraint called default. Default, for example, registration date, which is data type, is date, and there is no size for that, just date. And you would like to, for example, all students should by default registered on the 30th of August 2020. Then you can use the default constraint, and then you can specify the value for that date. Oracle keeps this date in this format, which is day in 2 numbers, dash, then the month in 3 characters, then dash, then the year in 2 numbers, like this, between single quotation. You have to put single quotation around the date, because later when you insert data into the tables, also you have to put single quotation around the date and also around the varchar2s, but the numbers will not be having any single quotation around them. So this is a table called student. I would like to create it, and then click run here. Click run here, and then this would take a few seconds, and then we'll say table created. If you'd like to see how this table look like, then you can describe it. You can type describe student, describe student, and then you can highlight this command. You can highlight this command here to execute this command only, and then click run, and then we'll describe this table student you have just created, in which you will see a primary key has been specified by the number 1 here, which is the student ID. So this is the table name student, these are the columns, and these are the data type, this is the length in characters. By default it will put 7 here for the date, although you didn't put 7 here, but by default it will put 7 as the length of the date for this attribute. But number 1 here means this is it has a primary key, and the primary key is the first one here. But you can actually, if you have like composite key, like another key also contributes to the primary key formulation, then you will see 2 here. For example, if major is another primary key, because the table can have a composite key, that means more than one attribute making the primary key. In this case you will see number 2 here. But in this example there is only one primary key, which is this one, the first one, student ID. You will see 2 checks here, one on the major and one on the registration date. Why? Because here this one is the option for nullable. Nullable means could it be null or not. Of course the first 2 cannot be null. Why? Because here you primary key, automatically it will not be null, the student ID. And the second one is also cannot be null because you already specified it in your create table statement. You said not null. That means you cannot skip this one. These 2 are these 2 here, major and registration date, can be null. That means you can skip them when you insert data, but these 2 cannot be skipped. You have to insert them when you insert data into this table. You will see that the default date has been specified for this constraint 30th of August 20. So this is to create a table. This is a table where it has these how many constraints. Here we have like 4 constraints: primary key constraint, not null constraint, unique constraint, and default constraint. Let me create another table related to this, and I will show you that we can also show how we can see a foreign key constraint. That means a referential integrity, we call it referential integrity constraint. So here I have a statement that creates this table called section. I just put it here, and here it is. This is create table statement for the section table. Create table section, section ID, is var char2 10. That means it is also a primary key here because I put primary key, and location put comma because it doesn't have any constraint. If you would like to have a unique constraint, you put it like that. You put a space and then put unique. Or if you would like to have it not null, also you can put not null here. And here, for example, for this one, teacher not null, you can keep it like that. But later I will show you that what if I forget to put not null here, how would I change it. So that's why I would like to just create teacher and location without any constraints, and later I will modify this table with the alter command to add these 2 constraints to them, like unique constraint and not null constraint, as we will see later. With that said, let me just show you that I would like to specify one of these attributes, which is this student ID, which is the same like the first one with varchar 210, varchar 210, but this time I specify the student ID to be a foreign key for this table. So I can use this constraint here, foreign key, and then which key? The student ID, which is already specified here in my attributes in this table. You have to use the word references. References, R-E-F-E-R-E-N-C-E-S, references. References what? References is student table. Which field in the student table is a student ID? So basically I mean this one, student ID in the student table. With this being done, you are actually creating a referential integrity constraints, as we discussed in the previous chapter. when we talk about constraints. So this is what we call referential integrity constraint. That means, what does that mean? It means that you cannot insert a student ID in the section table unless that student ID is already found in the student table. We cannot insert a student ID in the section table unless that student ID is available in the student table. So first, when you would like to populate data, you have to populate or fill in the student table with the data to make sure that you have student IDs in the table, to make sure that students are registered, so there are students available. Then go to the section and then populate the section table. When you come to the student ID field here in the section table, you should understand that this student ID are nothing but the same student ID available here. So you can refer to those student IDs by what we call foreign key constraint, this one. So let me execute this command and see how it is done. So here again, the table is created, and then if you would like to describe this table, I would put describe. By the way, I can use DESC instead of the word describe spelled out. So here, describe section. So also, if you like to highlight, if you like to execute like that, it will give you an error. See, it says missing or invalid option because it doesn't know which to execute, this create table or this create table or this command. So you have to highlight the command that you would like to execute. In this case, I would like to highlight the section or describe section table and then click run, and then it will describe the section for me. As we could see that student ID, teacher, location, all of these are left nullable, but the first one here, which is the section ID, cannot be null, and the primary key here is already being specified on the section ID as I have it here. So this is basically the create table statements. I would like to alter, to make some change to this table, because the DDL I have three different commands I can do in DDL. What are these three different commands? One of them, like DDL, it can have create or alter or drop. These three commands are actually part of the DDL. DML commands are insert and then update and then delete. These three commands are part of this. So I'm going to use, I already have used create statement. I would like to use alter. What do you want to alter? You alter the structure. If you could notice the difference between DDL and DML, between data definition language and data manipulation language, is that these three is about the structure of the table itself. It doesn't have nothing to do with the data itself. It has only to do with what? With the table name, with the data type, with the data size, or with the constraints, with the field names, and so on. But it has nothing to do with the data itself. But DML, data manipulation language, has to do with data itself. Data. To insert what? Insert data. Update what? The data in the table. Delete the data in the table. So this about the structure, and this is the content. The first DDL on the structure of the table, and these are three commands, insert, update, and delete about the data. We haven't inserted any data yet, so before I insert any data, I would like to try this alter command. Alter command. So let me execute this command here, which is this command, alter table student, add grade. Add. I would like to add a field. Maybe I forgot to add a grade as a field here. So I have student ID, first name, major, and registration date. So I wanted to have grade on it, but I forgot. So what do? Shall I just drop the table and recreate it again with the grade attribute with it? Of course, no. I will leave the table created there, and then I will add another column, which is the grade. But this time I would like to give the data type number, and then the data size is what? 4. So here I would like to alter the student table by executing this command, and here the table altered. So I would like to to check to see if the table is altered by doing what? Again, describe student. You can see that I can write describe in lowercase or uppercase. Also, this one applies to all commands. That means create, alter, drop, insert, update, delete. All these commands can be written in capital letters or small letters. And everything here that you see here, everything, whether a field name or a data type or a constraint, it could be lowercase or uppercase. There is no problem with that. The only thing that is case sensitive is when you insert data in the table. So if you insert data in capitals and then we're referring back to selected, you have to specify the capital letters for what you have inserted. Or if you'd like to update something that inserted in capital, then you have to write it exactly as you inserted it. I will show you example when I come to that. But I would like just to mention that I can use describe student in capital like that, or describe student in a small like that. No problem at all. So let me execute this command here and see how this table look like. You see the table is the same as the table that I've created before, except that it now has this grade that I have added using this command, alter table command. Then I would like to add another to modify this grade. I used a data type that is number with 4, but I don't want to use a grade as number because I would like to put like A, B, C, something like that. So one character like A or B or C or D or F, something like that. So you have seen that here in this example the data type is number because I specified it here in this statement. But now I can alter this to modify using modify. Here I am adding a column, but here I am modifying the column properties by changing the data type from number to char and only one character. That means you cannot insert 2 characters or more. And if a student is getting A plus, you cannot put plus, or B plus, you cannot put B plus, just one single grade. But if you would like to allow the student to have like 2 characters, then you can put it here like char 2, no problem with that. Now you can execute this command, and then also you will see that the table has been altered. You can describe again and see that the data type has been changed from number to char with 2 lengths. Another command to execute is, remember when I said I was able to create the table with this section table without specifying the unique constraint on this teacher. So let me actually make a space here for myself so that I can show you this command here to alter the table section. So what do I want to do? I would like to add a constraint. You can alter the table by adding a constraint like this. Alter table section. This is the section table. I would like to alter to add a constraint to the teacher. How do you do that? You use alter again, alter table command, alter table in the table name section. Add what? Add constraint. Constraint. You have to spell it correctly. constraint. Constraint without s. Add constraint. Here you can give it a name. Why you would like to give it a name? Because later you can disable or enable this constraint if you like. So it is better, it works without having a name here, but it is better to give it a name so that you can remember that this is the teacher unique constraint, so that you can disable or enable it later as I will show you. But what is the constraint name that you would like to add? It is unique. So it is not a default constraint, it is not a not null constraint, it is not a foreign key constraint, and it is not any other constraint. It is a constraint called unique, same like I did in the previous table, student. Which field you would like to have it as unique? Between 2 parentheses you put the field name, which is this one, teacher. So here you would like to add you would like to change the table section, so alter table section. You would like to add a constraint, so add constraint. You would like to give a name to the constraint, so teacher underscore unique is the name of that constraint. And then you would like to specify what is the constraint itself that you would like to add. It is unique. And then which field that you would like to make unique is teacher. So this actually will add that constraint to the table. Again, I told you about this name, so you can actually, now it is enabled of course, but if you like to disable it, you can disable this constraint by specifying its name as I said earlier. So here, if you execute this command here like this, like alter table section disable, you can use the word disable to disable this constraint. You can use disable constraint. What is the constraint name? Earlier you gave it a name, right? Here it is. So the constraint will be disabled. So now, as if there is no constraint has been created. So here, when you execute this command, you will see that the table has been altered. So constraint actually has been disabled. Or you can use enable. You can use the word enable. So enable, that means it was disabled before. You can enable it so that teacher now will be unique. So you cannot insert a teacher again with the same name. So you have to change the name every time you insert a row. So this is how to add a constraint and how to disable and enable a constraint. Let me try inserting a data into my first table, which is student table. Let me remove all this so that I can have a space for myself here, and then put this statement, which is insert its statement. Okay, look at my fields and look at my values. The field that I have, section ID, location, teacher, student ID. I need actually the first table, student first. So I have to insert data into my student table. So let me put the student table first. Again, I have student ID, first name, major, and registration date. And remember, I have the grade as well. Grade, which if I describe my table again, I will see the grade on it. Describe student, because I have added that. Remember, I added this with char2 here. So actually I have this field that have been added to this table, which is grade with char2, like that. It has been added to it. So this is my table now, look like that. And then I would like to insert these values. So look at my insert statement. Insert into student. You don't say insert into table student. This is wrong. The word table is not mentioned in DMLs. The word table, table, is mentioned in the DDL. And you will write create table, table name. Drop table, table name. Alter table, table name. But in the DML, you don't mention the word table, you just the name of the table. So insert into table name, delete from table name, update table name. So you don't actually write the word table like in the DDL. This is a difference that you should remember. So my statement is insert into student values, and then the values here, since are varchar2, should have the values between single quotations, no more than 10, because this is 10. So here I have 1, 2, 3, 4. So I have like 8 numbers. So between single quotation. So it has to be put between quotation because it's varchar2. And then Ahmed is the student name. It is very important to mind the order. So here why? Because the first name comes second, as you have seen in the previous SQL result. The name, the first name, Ahmed is the first name, and then major is the CS. Everything here between single quotation, even the date. The date I put 30th of August 2020, so I can just put it like that. 30 August 20. But if I skipped it, the system automatically will give it a value which is 30th of August 20. And this is the grade which is B. I can put B plus, no problem, because here I have a 2 on this one. So this one will insert what? Will insert one row like that. But let me copy this one and then show you something very important. What if I skipped? What if I have another student like 5. His name is say Ali, in the same CS, and then the default is this, and then he scored A plus, something like that. All right, so this one will create a problem. Why? Do you remember what happens? It says unique constraints violated. Why unique constraint violated? Because here I put CS again for this student. His name is Ali. I put CS again, and here I put major unique. That means I cannot repeat the major. So you cannot have again the same major. So you can put, for example, ME. It will work, no problem. But let me now violate another constraint, which is this time I would like to violate the primary key constraint. Here again, a unique constraint violated, but this time is not the major. This time is actually the primary key, because the primary key is unique. So I cannot put 1 1 2 2 3 3 4 4 again. Okay, so you have to actually make this unique, different. You can actually put 5 5, no problem with that, and then this one will work, of course. So let me actually copy the second line for this exercise, and then here this one was going to work, because if I put, for example, CE or ME or something different, then I can just click here and then another row inserted. You can see the values by executing the select so select all, star means all, from table name student, so highlight it, and then this one will give you the values. This I inserted, these two students have been inserted in the values. But remember, I have a default constraint which is 30th of August. So why am I putting 30th of August? For example, somebody is registered actually on 30th of August. Why should I put 30th of August again if I have it as a default here? So what happened if I skipped it? So let me just try to create another insert statement. This time I'm gonna put like 6 6 and then Saad, for example, he is in ME. I have to actually try to keep all the restrictions that I have imposed on this by putting these constraints, and then everything is here look fine, right? But here I would like to skip this one. I don't want to put the date, because I would like the system to insert it automatically for me. And then this student, he has got for example a C. Will it work? Of course not, it will not work. I will show you why. This time the error is actually complaining about not enough values. Why not enough values? Because it will look to how many values, how many fields, 1 2 3 4 5, and how many values here, 1 2 3 4. So how do I fix this problem? I mean, I already put 30th of August as a default, so that I don't want to put it. In this case, you don't have to, you don't really use insert into table statement like this. Here you have to specify the fields that you like to insert. In this case, you would like to specify the fields in order for this. The student ID, and then comma, and then the first name, and then comma, and then major, okay, and then after major the grade. You skip the registration date. Why? Because here you have only values for student ID first name, major, and grade. So if you would like to make use of the default values specified in your create table statement, you have to write the field names that you would like to insert between parentheses after the table name in the insert statement. So this one will actually going to insert sorry, let me highlight this one only and then run it. Will insert that values. As you can see that although I did not insert any date here, but automatically you will find 30th of August inserted because that was specified in the create table statement, as we have seen earlier here. Here it is, this one. So again, if you would like to make use of the default constraint value, then you have to specify the fields that you would like to insert in the insert table statement, and then also put them in the order here in the values. Okay, so this is how about using insert statements. Now let me actually try to violate the foreign key constraint and see how this one works. This is very important for understanding the referential integrity constraint, which is the foreign key constraint. All right, let me just put the that table, which is the section table I have created, in which there is some values referring to the previous one. So here, let me put it here. Okay, let me just put it here for this table. All right, section. Now look at the student ID. Is a foreign key right here. Foreign key, student ID, references, student ID. So what does that mean again? I mentioned in the beginning of this video that you are referring to values already inserted, values of student ID already inserted in the student table, like these values, these three values already inserted, that you have seen them here in the table. 4, 4, 5, 5, 6, 6. So that means you cannot insert into section values for a student ID that are not available in the student table. So let me try this statement. Insert into section values. Okay, for section ID I will put section 102. For location I will put room 105. For teacher I will put Zain. Make sure that later when you insert another teacher, you cannot skip that teacher. It is not null. You have to insert another teacher. It could be the same teacher or different teacher because there is no unique constraint for the teacher. I did not make unique constraint for this one, did I? Let me see what I did. I think we created a unique constraint for the teacher for this. We enabled the constraint, or we disabled it. I don't remember that. Let me just try this statement and see how it works. But for this one I would like to put 77 instead of 66 and see what happens. Let me see what happens. This one is violating the integrity constraint, which is referential integrity constraint. The violation here is because I put 77 and 77 is not even a student. I cannot insert a section with a student that doesn't exist. But if I put 44 for this, then it will be inserted. And then because 44 is a student available, and then let me insert one more student, one more section. So here I have 102, room 106, same teacher, different student ID. This one will violate one of the constraints. This time it is a primary key constraint because I cannot put the same section. Section ID is a primary key, so you can actually put 103 for example, and then you can insert that student but here it says unique constraint violated. That means mamoon.teacher.unique. That means you cannot insert. Yeah, I remember that I created a unique constraint here, so I cannot insert the same teacher here. So for example, you can insert another teacher. For example, Amrani is a teacher of this section, so I can actually use this insert statement so that you can insert that section. So now two sections have been inserted, and you can see that here in this select all from section. So you see location is not unique, so I can insert different locations, but teacher is unique. I cannot repeat a teacher here. Can I insert another student, the same student here? So what if I would like to insert another section, but this section is actually for the same this student 5 with another teacher. For example, I have teacher, his name is Asim, and the same student is taking in row 1-3 here, but you cannot have the same section, so I can change this one to section 101, for example. Does this work? What is any violation here in the first field? No, because each field here, each value for this field is unique, so it is a primary key. Here there is no constraints have been created. Here there is a constraint which is unique, but I am not putting a value that repeats. Every teacher is unique. Here there is a repetition, which is the same student 5 who was the student that student has been inserted 5. The student 5, his name earlier here was Jabir. So what happened to this guy? What will happen? Will he be inserted? Yes or no? I would like to insert this student again, student ID. So this is a foreign key, right? A foreign key constraint, which refers to the same student in that section student. No problem at all, because a foreign value can repeat. A foreign value can repeat, but a primary key cannot repeat. So here you will see that this student with the ID 11223355 is inserted twice here in this section because he is registered in two different sections, 101 and 103, with two different teachers in two different locations. But if you'd like to select to know who is that student, you have to make selection from two tables. Like select, for example, first name, and then first underscore name, student ID, and then you can use another field, like the major, who is the major of that student, what is the major of that student, and then from section you can use section ID, and then also you can use teacher from this section, from section table, and in the from statement you have to use from student and section, both of them. So you have to use from student comma section. That means two tables, not one table, because the first name, student ID, and major and section ID and teacher, section ID and teacher, they come from where? They come from the section table, while first name and student ID, they come from basically first name comes from the first table, from the student table, but student ID comes from both tables. So that's why you have to specify the table name here before the field name. So here you have to use student dot student ID, because if you don't do that, it will tell you that common ambiguously defined. I'm going to show you this in a minute. So let me remove it for now. From student section, where in the where clause you have to specify this relationship, like where student dot student ID equal section dot student ID. It means what you are doing here, student ID equals section dot student ID. That means you want to make the relation between the two tables such that the student ID in the student is the same as student ID in the section. So this one, student ID in the student table, is the same as student ID in the section. So this is where you have to add it here in the where clause. Why student dot student ID equal section dot student ID. But as I told you that the first student ID here in the select list, you have to precede it with a table name, because this one will give you this error, which is column ambiguously defined. It basically goes to this one. So here you have to use student dot student ID. That means the student, because here basically is asking you mention student ID. So from which table do you want me to refer to the student ID? Do you want me to refer to the student ID in the student table, or you want me to refer to the student ID in the section table? So here you are actually telling the the database management system to refer to the student ID in the student table. In this case, it will actually show you all student registered with the sections. So here, students with the section, there are 3 students registered here, and this shows twice because he has 2 different sections, 103 and 101, with 2 different teachers. If you don't provide this one, wire clause, it will produce what we refer to it in in the previous chapters as Cartesian product. Cartesian product is the number of values in the first set multiplied by the number of values in the second set. That means how many students I have. So select all from student. So how many students do I have in my student table? Let me see how many students I have. I have 3 students. Okay. Now earlier, guys, in that result, in the previous result, why Saad was not showing? Saad was not showing because he is not registered in any section. If he registered in any section, he would have he would have came here in this statement. Because when I inserted values for 4 and 5. But Saad is 6 here, so he's not inserted in this values. But I'm talking about Cartesian product. Again, Cartesian product means the number of values in one table multiplied by the number of table in the other table. So how many rows here selected? 3. Let me, how many sections I have? I have 3 sections. So 3 times 3 is 9. So simply, this is statement. If I don't use this where clause, it will give me 9. If I don't use the where clause, it will give me 9 records. As if everybody is registered in every section. Let me just cut this one and then remove the where clause and then execute it. It will give me 9 rows. Why 9? It will show that Ahmed is registered. Ahmed is registered in every section. Jabir is registered in every section. Saad is registered in every section. And every student is taking a section with one of the teachers. So yeah, Ahmed has 3 teachers because he has 3 sections and so forth. The Cartesian product is because of the lack of the connection relationship between the 2 tables, between the 2 relations. So here, when we implement this in an Oracle or in database management system, we have to provide this wire clause in which you are actually talking about referential integrity. This is why we say referential integrity is so important, that actually links the table through a common field. This common field is a primary key here in the student table, and a foreign key here in the section table. So for this one, it will provide the exact match if you put the wire clause, as you will see right here. So if you run here, you will see that the result is only 3 records, and this is exact match, and it shows that only Ahmed and Jabir are registering on these sections. Earlier, when I got the 9 rows returned, I can see also Saad registering in 3 sections, even though Saad actually did not even have any sections here. He's just a student registered, but he doesn't have any section according to my inserted statement earlier. So you have to provide this wire clause to avoid the Cartesian product situation. This is basically the solution for this first lab. Show you some example of DDL and DMLs, and we'll just do last two statement, which is update and delete. For the update statement, I would use, for example, I would like to change this teacher from Asim to, for example, say Sabir. How do I change a teacher here? Maybe I registered this section 101 by mistake to Dr. Asim. But basically this section is taught by Dr. Sabir. What do? You have to use the update statement. So you have to use update. I prefer to use capital letters for the commands and small letters for the table name and the field name. So I would use update, update what? Update section. Update section. Why update section? Because the teacher is actually here found in the section table, not the student table. Update section. Set teacher equal Sabir. So you have to put this between single quotation. But if you executed this statement, all teachers will be set to Sabir, even these two teachers, Zain and Amran, will be set to Sabir. When you specify the field to be changed, the value of the field to be changed, you have to use a wire clause to use for which section that you want, to change the teacher for. Remember, when you inserted values for this section, you insert this section with a unique identifier, which is section ID, which is 101 for this teacher. So here you have to use that primary key. So you have to use wire section ID with the wire section ID equal 101. That means you would like to change the teacher for only this section, not 102 and 103. So this one will change that teacher from Asim to make it Sabir. So when you execute the previous statement, you will see that this teacher now is changed to Sabir. And even in the table itself, you will see that this from the 2 tables, of course, this data. But in the table itself, if you use the select all from section, you will see that this teacher for this specific section has been changed to Sabir for section 101. All right, now this is the update statement. Use update and then the table name and then set, 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 and then the field that you would like to change, and then equal, and then the new value, and then the wire clause, which actually restrict this updates to specific values instead of all values being updated. So specific values will be updated. Okay, what happens if I would like to delete a student? Let me try to delete a student. Let me show how many students I have. I have these 3 students, right? Ahmed, Jabir, and Saad. Assume that I would like, for example, I would like to delete this student ID. Student name Saad with specified with this student ID. So I can use delete statement. Delete from student where student ID equal this ID. So I would like to delete, because if you said delete from student only without where clause, again you will delete all students. But here I would like to delete a specific student. So use delete from student, delete from student from the table student where student ID equal this. Now this one will not work. It has some sort of it is an error. That's referential error. Again, referential integrity error. All right, here it is deleted first because Saad doesn't have a registration. So what if I have to delete 5 will not be deleted. Why? Earlier Saad was deleted because he doesn't have any course registered, but now 5 or 4 these 2 students will not be deleted. Why? Let me explain that. This one also, it has the same error. Integrity constraint violated. Why integrity constraint violated? Because child record found. That there is a child record found. That means these students registered for sections. You cannot delete them. So if you'd like to delete them, you have to delete their sections first before you delete them. That means child record found. That means there is a child related record. If you'd like to delete the parent, you have to delete the child. If you'd like to delete the parent, you have to delete the child. You cannot delete the parent where it has a child existing. That means the parent table that relates to the child table, the parent table is the student table, and the child table is the section table. So what if I would like to delete student 4. If you'd like to delete student 4, you have to see which section that student is registered on. Delete that section first, or all section that student is registering on, then you can come and delete this student. So let me use select all from section and see which section this student is registered on. This section 4 is registered on this section 102. So if you'd like to delete the student completely from this major, so you have to delete this section. You have to delete the section because this section, this student is registering in that section. So in this case, you have to use delete from section where section ID equal 102. Once you delete this section from that student, then you can come here and you can perform this and then the student has been deleted. Now you can see that, select all from section. Now this section table does not include select all from section here. This section does not include 102. 2, and then also you'd like to say select all from student. You will see that this student table does not contain that that student. His name, his ID is 44. Alright, so this is basically some DDL and DMLs for this exercise, and then we will create more exercises to actually strengthen the understanding of this of these two languages.